All right, yesterday we finished up with question number 7. Today we talked about 8 through 11. I'm not going to cover all the questions, but I will go through the basis of what it wants us to understand here in question number 8. And really, it wants us to understand the fact of solving. And we kind of sort of know how to solve. There's a couple of things we don't know how to solve. They're going to use graphing to help us make this connection. And in the first one it says graph the function. Well, in order to graph the function I have to know A, H, and K if they give me a problem in vertex form, which they do. A is 1, H is 1, K is -4. So I'm going to go ahead and graph 1 and -4. And what that's going to do is that's going to give me what my line of symmetry is, which is x equals 1, because the vertex is 1 and -4. So I can answer those two questions. And it says, what are the x-intercepts? Well, I need to finish the graph. So write 1 up 1, write 2 up 4, write 3 up 9. Well, back to the x-axis is 4, so 5, 6, 7, 8, 9. There's 3 anchor points on the right. I'm going to mirror that on the left. Finish my graph, and it tells me that the intercepts are -1 and 0 and 3 and 0. How far are the x-intercepts from the line of symmetry? Well, the line of symmetry is x equals 1, 3 minus 1 is 2, so plus 2 to the right, plus 2 to the left, so I'm going to say plus or minus 2 on either side. Now it says use inverse operations to solve. How do I use inverse operations? Well, again, the goal in solving is to get x by itself. 0 is equal to, so the first thing I need to do is add 4 to both sides. So 4 is equal to x minus 1 squared, not 2. I was thinking of the exponent of 2 there. X minus 1 squared. How do I unsquare something? I square root it. So when I square root something, the square root of 4 is 2, but it's plus or minus 2 is equal to x minus 1. That's going to get rid of the exponent. Then I simply add 1 to both sides, and therefore x is equal to 1 plus or minus 2. What they want you to notice here is 1, here's my axis of symmetry. On the x-axis I can go plus 2 units to the right, or I can go minus 2 units to the right. And if I add, 2 plus 1 is 3. Or if I subtract, 1 minus 2 is -1. There's your x-intercepts. Make the connection. I'll show you one more. Because it says sometimes if we can factor, we want to factor, which the other one we could. This one you can't, because they're factors of 4 that give you 6. That doesn't happen. So it wants me to graph the function by putting it in vertex form. Divide by 1, move c. So x squared minus 6x plus something and 4 minus something. That's going to be equal to 0. I'm gonna, well, actually it doesn't even have to be equal to 0. I'm gonna graph it because it's going to convert it to vertex form. So when I do this, what am I going to get? Well, that's step number 1, divide A, move C. Step number 2 is take half of the middle value. That's -3 squared is 9. This, what I take half of, if you remember, helps you build your equation. That's your h value. So this is going to be equal to, f of x would be equal to 1, which is my a value, x minus 3 squared, and now all I have to do is find out what my k value is. Well, that's simple. 9 goes in the blank. I ask myself, what am I really adding? I'm really adding 9 times 1, my a value, which is 9. So I subtract 9. 4 minus 9 is -5. My vertex is going to be +3 and -5. My line of symmetry is going to be x equals 3. And then it says, what do you estimate the x-intercepts to be? What do you mean, what do I estimate them to be? Well, watch. When we graph, watch what happens. I'm going to graph +3, -5. 1, 2, 3, 4, 5. I'm going to graph according to a pattern. Right 1, up 1. Right 2, up 4. Right 3, up 9. So 5, 6, 7, 8, 9. If I have my 3 anchor points. If I graph this half the parabola, you'll notice that this half the parabola, it crossed the x-axis between 2 whole numbers, between 5 and 6. Now I'm going to graph the other half. Left 1, up 1, left 2, up 4, left 3, up 9. the other side crossed between 0 and 1. So what do you estimate them to be? What we said in class was between 0 and 1 and 5 and 6. In other words, we couldn't factor this because no factors of 4 give me 6. So as in class I stated, if you can't factor it, your x-intercepts are probably decimals. Well, that's proof. What do you estimate the distance from each x-intercept to the line of symmetry is? Well, if the line of symmetry is 3, I'm going to estimate that distance to be 2 point something, or just over 2. 2.2, 2.3. Again, it's estimating. F says start with vertex form and solve. Okay, so x minus 3 squared minus 5 equal to 0. I bet you I'm going to get an answer that's 3 plus a little bit and 3 minus a little bit, and that little bit's going to be just over 2. How do I know that? Well, I'm going to start by adding 5. So 5 is equal to x minus 3 squared. Again, all I did was add 5 to both sides. At this point, I'm going to take the square root of both sides. Why? Because I want to get rid of the exponent. When I do so, you're going to sit there and go, well, wait a second. The square root of 5, I don't know what that is. I don't know what it is either, and I don't have to know right now. All I know is that plus or minus the square root of 5. If it was 4, it'd be plus or minus 2. But I'm not concerned about that. Okay? I got rid of the exponent. That's what I'm concerned with. Now I add 3 to both sides. So plus 3 plus 3. So x is going to be equal to 3 plus or minus the square root of 5. Leave it as a radical. Why? What's a radical? A radical is just a decimal. Think about what the square root of 5 is. The square root of 1 is equal to 1. The square root of 2 is equal to, I don't know. The square root of 3 is equal to, I don't know. The square root of 4 is equal to 2. And then we have the square root of 5. Well, if the square root of 1 is 1 and the square root of 4 is 2, 2 and 3 fall somewhere between 1 and 2. Maybe 1.2 and 1.6. I don't know. The square root of 5 is going to be 2.1, 2.2. It's going to be more than that. So really what this is saying is 3 plus or minus about 2.2. That's really what that's saying. Go back and look at E. What do you estimate the distance from each x-intercept to be? Just over 2. This is just over 2. My line of symmetry is 3. The distance is just over 2. So 3 is my line of symmetry, just over 2 to the left, just over 2 to the right. That gets me to my x-intercepts. I lied. Last question here. Solve the equation by completing the square and using inverse operations. Divide A, move C. X squared minus 6x plus something, 7 equals 0. Half of 6 divided by half of negative 6 equals negative 3 squared, which is 9. How much am I really adding? I'm really adding 9, so I'm going to subtract 9. There's your 3 steps in converting to vertex form. Pretty simple. Boom, 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 done. Write your equation. A is 1, so it's going to be equal to x minus 3 squared minus 2. What's the line of symmetry? Well, I got to solve using inverse operations. I'm going to add 2, so 2 is equal to x minus 3 squared. I'm going to take the square root of both sides, plus or minus the square root of 2. Remember, it's not a perfect square, is equal to x minus 3. I'm going to add 3 to both sides. Therefore, x is equal to 3 plus or minus the square root of 2. My line of symmetry, notice I didn't graph it, so I can't verify it visually, but I know that that's my line of symmetry, and I'm going to go the square root of 2 to the right and the square root of 2 to the left along my x-axis. So if I'm going to graph, here's my graph. If I come out to 3, I'm going to go a little bit to the right, and I'm going to go a little bit to the left, whatever this is, which is approximately, what did we say it was? We said it was, if I go back up, 1.2. So 3 plus 1.2 is 4.2, a little over 4. Those are going to be my x-intercepts. Wherever the vertex is going to end up, I don't know. All right? But ask questions as you need to.